Good day, dear students. Myself, Professor Kumbar Sagar Dinkar, as a teaching faculty of Physics Department from Chhatrapati Shivaji Junior College. In a previous lecture, we studied the definition of circular motion, centripetal force, and the first application of circular motion as a banking of road. Now, today we discuss the second application, conical pendulum. This article asked for 3 marks in the board examinations. Now, what is a conical pendulum? What is the definition of conical pendulum? A point heavier mass suspended by inextensible and weightless string from a fixed rigid support, and it is rotating in a horizontal circle with constant speed, then it is called as conical pendulum. I repeat the definition again. A point heavier mass suspended by inextensible and weightless string from a fixed rigid support, and it is rotated in a horizontal circle with constant speed, then the pendulum is called as conical pendulum. I explained this definition again. Let us consider there is one bob or heavier mass which is suspended by inextensible and weightless string from a fixed rigid support. Now, this bob performing a horizontal circular motion, means in a horizontal plane. Due to this horizontal circular motion, it forms a cone or an ice cream cone. Now, when this bob performing a horizontal circular motion, then it is acted upon different forces. Now, calculation for different forces or the time period of conical pendulum. Let the small m, this is the mass of the bob, r, this is the radius of horizontal circular motion. Now, v is tangential velocity of the bob. Theta is angle made by the cone or conical angle. Again, we know that the small g is acceleration due to gravity. Now, bob performing a horizontal circular motion. When this bob performing horizontal circular motion, then it is acted upon 2 forces. The first force is weight mg, weight of the bob mg vertically downward direction towards the center of the earth. Now, to balance the weight, there is a second force is created, and this second force is nothing but the tension T, and this tension T, which is along the string towards the suspension point of the conical pendulum, means this tension starting from center of the bob and towards the suspension point along the string. But from the diagram we say that, or it is observed that, the tension and the line of weight make some inclination with each other. Means this is a line of weight, this is a tension, make some inclination with each other with angle theta. This theta and this theta both are same. Hence the tension is resolved into 2 components. One is T cos theta and the second is T sin theta. I repeat again, the tension resolved into 2 components. One is T cos theta, this is a vertical component, and the second is T sin theta, this is a horizontal component. Again, see this diagram. From the diagram we say that the T cos theta, this is a vertical component balanced by downward weight, and the T sin theta, this is a horizontal component which is along the radius towards center of this circle. Means physics says that the force which is along the radius towards center of the circular motion is called as centripetal force. Means the T sin theta, this horizontal component is same as centripetal force. Hence, from equilibrium condition, T cos theta is balanced by weight mg and T sin theta is equals to centripetal force. But we know that the value or the formula of the centripetal force is mv square upon r, where m is mass of the bob, v is velocity of the bob, and r is radius of circular motion. Now divide equation 2 by 1, we get T sin theta divided by T cos theta. T get cancelled, we get tan theta, and mv square upon r divided by mg, get cancelled, we get v square upon rg. Hence, the tan theta in the conical pendulum is equals to v square upon rg. This is equation number 3. Now expression for time period of conical pendulum. Then what is the time period? The time taken to complete one circular motion in the conical pendulum is called as time period of conical pendulum. Now, this time period calculated as, we know that the general formula of the time period T is equals to circumference of the circle divided by linear speed. Means here bob performing a horizontal circular motion. During the circular motion, it covers a circumference. A total distance covered by the bob is equals to circumference, and the circumference of the circle is equals to twice pi r, and the v is linear speed of the bob in the conical pendulum. Hence, the time period T is equals to twice pi r upon velocity. It is equals to 2 pi into r upon v. This is equation number 4. Now consider this diagram. In this diagram, the point O is suspension point, point C is center of horizontal circle, A is position of the bob in the conical pendulum, theta is angle, H is height of cone, L is length of simple pendulum. But the length of simple pendulum always measure from center of the bob to the suspension point. From this diagram, by using simple trigonometry, we say that tan theta is equals to AC upon OC. Tan theta is equals to opposite side AC upon adjacent side OC. Hence tan theta is equals to AC upon OC is equals to R upon H. This is equation number 5. Again we know that the previous equation of tan theta in the conical pendulum, tan theta is equals to V square upon RG. Equating equation number 5 and 3, we get equation 5 and 3, we get V square upon RG, V square upon RG is equals to R upon H. Now, V square upon R square is equals to G upon H, that is V upon R is equals to square root G upon H. By taking square root, we obtain equation number 6. Now put equation number 6 in equation number 4. Now put this value V by R in this equation. We get here R by V. Now R by V means inverse of this. Inverse of this is equals to square root H upon G. Now put this equation 6 in equation number 4. We get the time period of conical pendulum 2 pi square root H upon G, where H is height of cone, g is acceleration due to gravity and 2 pi is constant. Now height of conical pendulum changes continuously. Hence this height is replaced by constant value of length. And consider again the same triangle OCA. In the OCA, by using simple trigonometry, sin theta is equals to R upon L. Hence, and again cos theta is equals to H upon L. Hence, H is equals to L cos theta. Now put the equation B in this equation, we get or replace the value of height by L cos theta. We get the time period of conical pendulum 2 pi square root L cos theta upon G. This is an expression for time period of conical pendulum. Now see again this formula. Time period of conical